Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the reaction type by examining the substrate and reagent. The substrate is HDCO, formaldehyde with one H replaced by deuterium, i.e., deuterated formaldehyde, HC, is equal to O, D. The reagent is H18O isotopically labeled hydroxide. The products are DC, is equal to O-18O A formate carboxylate anion bearing the labeled oxygen, and CH2D of a deuterated methanol, acting as the alcohol product. Moving on to the next step. Recognize the Cannizzaro reaction. The Cannizzaro reaction is the base-catalyzed disproportionation of an aldehyde lacking alpha hydrogens, no alpha-H. Here, HDCO is a formaldehyde derivative with no alpha carbon hydrogens. The carbonyl carbon itself bears H and D, but there is no separate alpha carbon, so it undergoes the Cannizzaro reaction. Under base, or dash, one molecule is oxidized to the carboxylate and another is reduced to the alcohol. Moving on to the next step. Confirm it is the standard, not cross, Cannizzaro. Both reactant molecules are the same aldehyde, HDCO, so this is the standard, self, Cannizzaro reaction, not a cross Cannizzaro, which involves two different aldehydes. This eliminates option C. And for the final step. Disproportionation. In a disproportionation reaction, the same species is simultaneously oxidized and reduced. Here, one HDCO molecule is oxidized to the carboxylate, DQ-, and another is reduced to the alcohol, CH2D-O. This is exactly disproportionation. The Cannizzaro reaction is inherently a disproportionation and also a redox reaction, but the more precise and specific classical term applied to it is disproportionation reaction. Options B and D incorrectly name it the Tischenko reaction, which produces an ester, not an acid-alcohol pair. Option C incorrectly calls it a cross Cannizzaro. Option A correctly identifies both names, Cannizzaro reaction and disproportionation reaction. Isotope labeling conformation. The 18O from H18O appears in the carboxylate product, DC, is equal to O-18O-, consistent with the Cannizzaro mechanism where hydroxide attacks the carbonyl carbon and the labeled oxygen is incorporated into the oxidized product. The alcohol CH2D retains the original unlabeled oxygen from the original C is equal to O of the reduced molecule. This mechanistic detail confirms the Cannizzaro disproportionation pathway. Therefore, the correct answer is A. Therefore, the correct answer is option A.